Good morning. Welcome to our second event on Azure Stack HCI, focused on version 21H2 being released later this year. We'll be covering off many of the new capabilities in this session and the overall operational benefits these will bring, while also delving into the new technical aspects. My name is Terry Story, Chief Cloud Officer at Aquitect. I would also like to introduce my co-presenter for today, Lee Harrison, Operations Lead for a major service provider in the UK. But before we dive into this session, I would like to first remind everyone on our previous Azure Stack HCI session delivered on the 26th of June, and you'll see this in the next slide. We discussed public cloud and hybrid cloud, data sovereignty, regulation challenges, and where Azure Stack HCI and Azure Arc helps accelerate the first steps to cloud from a familiar starting point. And I provide a link to the video for this below. Please review this video to provide further context on the challenges of cloud and how Azure Stack HCI and Azure Arc help in the journey to hybrid cloud, especially if Azure is your direction. I would also like to offer the opportunity to attend demos after this event for both multi-cluster monitoring and GPU high availability. Please send requests to the following email address for these demos. Now, this event today really builds on, the session that we did on the 26th of June. And this delves deeper into the technologies that enable this, while also outlining the improvements to overall operational posture. But before we delve into the details on Azure Stack HCI 21H2 capabilities, we really need to take a moment to understand today's operational challenges and what is required to fully address these, and can think of no better way to articulate them than as a customer who lives and breathes these each day at scale, managing many clusters and thousands of virtual machines. To cover this important area, to set the scene for why Azure Stack HCI 21H2, I would like to hand over initially to Lee Harrison from a customer perspective on today's operational challenges. Over to you, Lee.
Hi, good morning, everyone. Thanks, Terry. And first of all, I'd like to thank Terry and Aquitect team for inviting me along today. As Terry said, I'm Lee Harrison. I'm an operations lead for a hosting company. And my main aim today is to give you an insight into the way that I approach solution design with the technology currently available. So I've been doing Hyper-V clustering for the last decade, using the major Windows Server versions, running thousands of VMs across multiple clusters and running hundreds of thousands of services on those clusters. And it's been an interesting journey. So I caveat the following with these are just my opinions based on my experience. So based on my experience, I've come up with a recipe for design with these main considerations. So first of all, I always start with using validated hardware. OEM validated hardware that's supported for Windows Server, HCI, Azure Stack HCI is the best place to start. I always make sure I've got the appropriate network speed to accommodate my throughput. RDMA is an absolute must with a minimum of 25 gig interfaces. I try and keep my design as simple as possible. And for example, if you don't need SDN, stick with the traditional networking and don't use dedrup. That's just my experience. Again, to keep complexity down, I try and stick with a flat single tier system, e.g. all flash. Caching is fantastic in S2D, as we know, but for large scale solutions, it's just a little bit more complexity and additional overhead to monitor. So I've learned to take responsibility for my own business continuity and disaster recovery. Your clusters will have problems, and it's up to you to minimize the impact to your business and your services. Understand your workloads, track and be aware of metrics like IOPS, latency, capacity, and what your workloads need to run. Have good support agreements. When issues occur, vendors really can provide excellent help, and have decent monitoring, not only for component failures, but monitor performance as well. So this recipe has kind of led me to one of my latest solution designs, and this is a single platform, a single solution, and it's made up of 32 nodes with 8 4-node clusters. and it's been designed to run well over 2,000 VMs. Now I've chosen to go to 4-node clusters as that gives me smaller failure domains. The clusters are deployed in pairs with all VMs replicated to a partner cluster using Hyper-V Replica. They're based on all flash storage, single tier, and they've all got 25 gig RDMA iWarp network interface cards. Now, the main benefits this gives the platform is there's less impact if a single cluster fails with the smaller failure domains. All VMs can be failed over to another cluster if needed. If a single cluster did have a really bad problem, then we can bring workloads up within an hour or two, which meets a decent SLA. The flat storage system kind of guarantees consistent performance, and again, it's less overhead to monitor the caching tier and your working set size. With 25 gig RDMA, network throughput is not a bottleneck for these particular clusters, and I get faster repair times due to less data to resync on smaller clusters. Now, although this design has proven successful, it hasn't been without its challenges, and the main challenges are around monthly patching for Windows and hardware updates. It just simply takes time to patch clusters, as I'm sure we're all aware. I have hit stability issues while updating in the past. I've had performance impacts when rebooting nodes, and I'm getting to the point where there's just simply too many clusters to update for a small team manually each month. With replication, and again, I'm using Hyper-V Replica, this doubles the number of resources per cluster. Now, particularly with 4-node smaller clusters, the amount of resources that running VMs or stopped VMs has an impact to cluster stability. The constant replication requires more resyncs, so when you're rebooting a node and those disks are offline and the extents are getting invalidated on the rest of the nodes because there's more writes coming in for a replica, it just adds to a longer repair times when repairs kick in when the node comes back up. There's no dedicated management tool for Hyper-V Replica, and we rely on scripting. And Hyper-V Replica doesn't seem to work nicely with other technologies like backups and dedupe. So the current measures that we put in place to try and address some of these challenges are looking at using cluster-aware updating. Now, we haven't automated it in terms of set a schedule. We run CAU manually based on confidence and getting our patch window in the right state. And also, to mitigate the impact of latency spikes when rebooting nodes, we use a pre and post script in CAU that enables and disables storage maintenance mode. And we've found that CAU just isn't viable for older hybrid clusters, but as the repair times are just too long. And if you're running things like backups, the window of opportunity just is too small to be able to fit CAU cycle in. For the hardware updates, we're reliant on WAC OEM extensions. Again, it's a manual process and it can take time if there's a lot of updates, a lot of hardware updates like BIOS, NIC drivers, firmwares to update. And also, if there is some hardware updates, it means it's a separate process to Windows updates, and that means 2 rounds of updates to every cluster each month, which just doubles the time it takes to get these things into a updated status. And with Hyper-V Replica, what we've been able to do is pause replication before we reboot nodes for updates, and that seems to minimize the impact on repair times. And we're using custom scripts to set up replication and custom monitoring for replication failures. So for the future, I really feel that we've done everything at the moment to mitigate challenges and put measures in place with the current technology stack. And I feel now that I'm kind of dependent on the vendors for future improvements to help me manage and minimize operational overheads and to manage these clusters in a more efficient manner. And so I'm really interested in how Azure Stack HCI can help us in the future. And with that, I'd like to hand back over to Terry.
Thanks, Lee. Thanks for that overview. This really helps put things into perspective and frames the discussion around Azure Stack HCI 21H2 as we dig deeper into its new capabilities and operational improvements. For the benefit of everyone on this call, 21H2 translates into year 2021 second half. So we're nearly into August 2021. So now, there's not much longer to wait before this becomes generally available. Now, as we really think about Azure Stack HCI, when this really began back in October 2016 with Microsoft HCI, it's been a 5-year journey so far. Microsoft HCI is in its 4th generation, now called Azure Stack HCI, unique product in its own right, and is highly established with over 40,000 clusters deployed to date based on recent telemetry. This data is a combination of Microsoft and OEM reporting based on systems sold and telemetry reporting from each cluster out there in the live. And as we know, not every customer and cluster is switched on for telemetry. So I expect that number to be substantially higher than that. But to just give you a flavour for the established solution and the numbers out there, Azure Stack HCI is a cadence of 2 releases a year, bringing innovation at a pace that was never available on Windows Server. Windows Server released it once every 3 years. What a stark difference. This is important as it enables new innovations, often that bring real value. And as you're paying for a subscription service, this has to provide something for you continuously, for you to want to be continually paying that subscription. For example, why would you pay a monthly subscription to Netflix that has to provide a service that you want, is simple and easy, and has to keep innovating and delivering what you want for you to want to keep paying that subscription? Azure Stack HCI is to provide a similar type of value, but in terms of operational improvements and new capabilities that solve your real world problems. This is the theme of Azure Stack HCI. Now to shift gears to upgrades. Once on Azure Stack HCI, there's no more forklift upgrades to the next release or project planning of upgrades to next releases. This now becomes an automatic in-place rolling upgrade that will maintain business continuity through cluster-aware updating. The upgrade is available through Windows Admin Center and PowerShell and is currently subscription-free as a public preview that you can join today. Now onto extended support. At Microsoft Inspire, there were further announcements for extended support. Today on Azure Stack HCI 20H2, this supports Windows Server 2008 R2 and 3 years extended support, which is now down to 2 years. This has now been extended to support 3 years for Windows Server 2012 R2 from October 2023 when it goes into extended support. So let's now start thinking about Azure Stack HCI and its enterprise capabilities in terms of a software-defined data center. This slide here is quite a noisy slide, but I just want to highlight some of the kind of enterprise type capabilities, unique capabilities, and the new capabilities coming in 21H2. And I'm going to go in further details into all these areas. So when we think about Hyper-V and Azure Stack HCI, this is the same type 1 hypervisor that's running in Azure today on over 1 million nodes, which is hyperscale proven. And so it's already enterprise ready. When we look through all the enterprise capabilities available in Spaces Direct, the Azure Stack HCI software-defined storage solution with 2-, 3-, and 4-way mirror, RAID 6, RAID 5+1 with nested mirror and accelerated parity capabilities, support for enterprise-level storage class memory, NVMe, SSD, and HDD, plus all the enterprise smarts to manage drive failures, retirement, and repairs to ensure data resiliency and redundancy, plus all the new features coming in 21H2. Again, enterprise ready. Then we go on to networking. Software-defined network is highly available, leveraging Azure Service Fabric to provide a resilient stateful solution. This comes with level 4 load balancers, distributed firewall, access control lists, and full micro-segmentation of standard VLANs, as well as overlay networks. Think also of Azure Stack HCI and Azure Arc native integration as enabling Azure on-premise capabilities, bringing proven technologies from Azure to on-premise, while also bringing operational improvements in terms of the wider lifecycle management at the same time. keeping everything familiar, simple and easy. I think that keeping everything familiar is the key thing here. Bringing cloud to a familiar environment, cloud at your pace, on your terms, under your budgetary control. Now, as we jump into storage improvements within 21H2, each of these new capabilities helps in the area they are intended, but also bring a unique set of operational scalability improvements that typically get missed. These are the areas we're going to focus on today because they're really important from an operational perspective. So let's dive into each of these. So if we take an extent, for example, extent is the smallest piece of data that is typically spoken about for Spaces Direct. You may also have heard about slabs. These are similar things and are used interchangeably. An extent is a contiguous boundary of data within Storage Spaces Direct in terms of its core, pool and metadata. Whereas a slab in its basic form is an extent plus fault domain, resiliency, an extent plus resiliency. Because Storage Spaces places slabs across all capacity disks evenly on all nodes in a cluster based on the fault domain of the volume, whether it's two-way mirror or three-way mirror, a slab truly represents the true layout across the disk, as there's always a fault domain, even on a single node, albeit the single node is set at physical disk rather than storage scale unit, and that's another set of different conversations. The pool metadata keeps track of all the slabs and is placed on 5 fastest drives across the cluster and is aggressively kept up to date to ensure optimal. So why is this all important? Well, when you patch a node and this node restarts, this can typically take between 2 and several minutes, depending on the age of the system. While this node is offline, the remaining nodes maintain a dirty region tracking table, keeping tabs on every write and invalidation of the extent. In the past, before Azure Stack HCI, a 4K write can invalidate a whole slab to be resynced. This could be a 256 meg or a 1 gig slab, depending on the storage tier used to create the volume. When the node reboots and rejoins the cluster, this will need to resync all of the data, which could go into hundreds of gigabytes. The impact on that and wait times and the impact of a patch lifecycle of a cluster, if you take hybrid and SATA disks and the speed it takes and the amount of data it needs to transfer, that could make the patch lifecycle of a cluster take days rather than hours. So how does Azure Stack HCI kind of help address this? Well, this introduces a new capability called sub-extents and granular tracking. Now, when a node is patched and reboots and writes occur, a 4K write will only invalidate a 256K sub-extent, which is the interleave size, and not the full extent, substantially reducing the data to resync when a node rejoins the cluster, reducing the overall time to patch cluster substantially because the resync wait time is far, far less. So you can see the theme here where we're going. We're going into detail of all the changes that exist in 21H2 and the impact from an operational patch perspective, and then from that process, how these improvements will speed up and simplify and just make that patch lifecycle much more kind of plannable. So if we go into FIM provisioning next. Now, FIM provisioning is only available on Azure Stack HCI 21H2. You have to enable update the storage pool to the next version, and this will enable FIM provision on the pool. So by default, when you create virtual disks, they are FIM provisioned. Then you would have to explicitly go in and say which virtual disk is FIM provisioned or fixed provisioned. So let's just say we've updated the storage pool to the next release. I now in Windows Admin Center get displayed a fixed provision and FIM provision option. I select FIM provisioning, and then from that point onwards in Windows Admin Center, I can create virtual disks and they are FIM provisioned. So what is the difference between a fixed provision and a FIM provision? Well, FIM provision initially requires a 10% footprint compared to an equivalent fixed provision volume, meaning initially there'll be less slabs, less things to resync on node reboots, improving the time to patch a cluster further. You can see the theme here. You still need to calculate the size of the volumes and the amount of volumes as if they were fixed volumes to match the amount of nodes in the cluster as you've always done in the past. A thin provision volume supports trim, and so it can shrink and grow the footprint based on moving virtual machines around the cluster. Storage migrate, for example. Okay. And as a side note, RFS volumes can only be expanded upon and cannot shrink. So thin provision really brings this kind of added benefit here. Another area to think about, is when you want to expand, from a 2-node to a 3-node cluster, or even to a 4-node cluster, with Azure Stack HCI 21H2 and thin provisioning in place already. This is actually made much, much easier because of thin provisioning. Firstly, you can add a 3rd node to an existing cluster with nested mirror and nested map thin provision volumes in place. You can just create any new nested, you can't create any new nested mirror volumes. The storage tiers have changed because you've got a 3-node now. And the fault domain is still tied to a 2 nodes for these volumes. But it does allow you, with that 3rd node, to create a new 3-way mirror volume that's thin provisioned, only requiring 10% of footprint compared to a fixed volume. So you don't have to double the capacity as you had to do in the past when upgrading from a 2-node to a 3-node. You've now only requiring 10% footprint, and so you don't have to, be so focused on, oh, I need, twice as much storage to be able to move, to create that fixed provision volume and move, storage migrate those virtual machines from the old volume to the new and translate the existing 2-node type design into a 3-node design. With thin provisioning, I can avoid all that. So essentially, if I'm running nested mirror, nested map with thin provisioning, and I expand to a 3-node, and I create a new 3-way mirror volume with thin provisioning, I can literally storage migrate those virtual machines, and trim will reduce the size of the volume of the existing volume, the source volume, and it will dynamically increase the volume of the new as I move the volumes to the new volume. So it's growing and shrinking dynamically, simplifying and making that transition from a 2-node to 3-node far, far simpler. And also, because thin provisioning is supported within a stretch cluster, I want to give you this example as well. There is a difference in a stretch cluster. So imagine that you've got a stretch cluster across 2 locations. You've got a storage pool in each site, volumes in each site, and they're thin provisioned. Storage replica, no matter the size of the volume, will replicate that volume in seconds in the initial sync rather than taking outs, because that volume could be terabytes in size, but because it's thin provisioned, it's a far, far smaller footprint to replicate. But the only challenge with storage replica right now is that it doesn't support trim. So essentially, as your volumes are growing, and you want to move your virtual disk from one into another, trim won't be able to reduce that, and that's just a support capability between trim and storage replica, and that's being looked at to actually get that addressed in the future. So just to give you a heads up on that side of things as well. So let's move on to the next capability, to the Spatie Direct throttle repair. This again is a 21H2 only capability. Now, I don't know if you guys have seen the documentation for this and tested this out, but essentially Microsoft talks about a queue depth setting in the throttle repair. This actually represents the amount of resync patches that can occur at one time. This doesn't represent the queue depth, of a disk and then the relevant IOPS per disk. This is still a background task. This enables an admin to increase resources allocated to storage repairs and regenerations. The default was medium. This is the same setting as 20H2 in 2019 and is the recommended default for as a start point for storage repairs. So what does this really mean, and how can I kind of plan to use this and obtain a benefit from this? Well, let's take a worst case scenario. If you think back to Lee's comments around a hybrid system with SATA disk configuration, well, the queue depth of each disk is 32. That's 32 IOPS per disk. Repairs and regeneration storage jobs would take much longer compared to a single tier all-flash system, which is queue depth times the amount of disks, and you don't have device cache in there. Now if you take the worst case scenario, it's a hybrid solution. It's 2-tier, it's SATA disks, and take that. I want to patch update my 6-node cluster in this, very slow storage configuration, over the weekend. I don't want to go longer than the weekend. This is where repair throttle will be used. But I have to plan this. If it's a hybrid and it's a SATA disk configuration, then I would certainly plan for outage. No one should be using the virtual machine because I'm going to be impacting those workloads. I may want to shut down those workloads if I can, but if not, yes, to keep those workloads, but no one should be accessing those workloads because performance will be impacted through this. So a SATA hybrid solution should be planned if you want to increase the speed of repairs, because it will impact those workloads. And so what this allows me to do, it allows me to set the setting above medium to high, which will then allow me to run multiple repair jobs and do a lot more processing of repair jobs quicker, which then with RDMA increases the bandwidth and also then equally will increase the CPU usage of the system. But the main thing is that it will impact the writes, because everything that you do on repair is the same as if you were writing to a SQL on a VM. It has to go into the device cache, and then it has to get destaged and lands in the capacity drives. And because if it's a two-way mirror or a three-way mirror, it has to be committed to those default domains across different nodes as well, plus RDMA. So there's lots of kind of aspects to this that as you now want to speed up and take more resources, could impact virtual machine workloads. So this really will help with a SATA, with a hybrid system, and it will impact workloads if you want to go above the medium, but it will mean that you can get home for dinner on the Sunday evening, because you can speed up the repairs, speed up the patch process, and get your cluster fully patched quicker. Whereas an alternative, where you have a single tier all flash with SAS, value SAS or NVMe drives, providing a queue depth of 256 or 1,000, 5,000 for each NVMe drive, this will be able to handle this higher setting much easier. So, to go to very high, as also have less impact to the storage and workloads. And as we move into PCI 4 supported drives, we're even getting better because there's a 30–40% increase in performance there as well. So again, this is really about giving you the tools to be able to adjust the way that the system will run to give you a better outcome or a faster outcome. But you have to be cognizant of SATA disks and hybrid systems with this particular capability. My recommendation is that single tier all flash all the way with every design of kind of S2D in terms of repairs and patching and getting that really fast operational turnaround. And when you think about this type of capability, especially with SAS drives and NVMe drives, single tier will eat this up, and you still won't have much of an impact on your workloads because the storage can handle it, especially if you've got dual 25 gig RDMA adapters or 100 gig RDMA adapters as you go to NVMe. So let's move further forward. So this table here talks about the different types of queue depths and Microsoft's recommendation for storage throttle. At the top end, you've got very high queue depth of 16, 8 for high, and 4, which is the default out of the box. And then you've got low and very low. So I think, in real terms, I think the medium out of the box is going to be the kind of typical all day long setting. But if you really want to kind of speed up and reduce your patch life cycle to fit this all in a weekend, so it doesn't go on for days and days, this gives you some more tools in the toolbox to consider. So let's kind of bring all of these storage improvements together and kind of focus on these from a customer benefit perspective. You can see a common theme here in terms of operational improvements. There's less data to resync on no reboots. Patching of clusters will be quicker, and you can simply more simply expand cluster nodes and adjust storage to fit. Now, as we, look at all those pieces, it really, comes down to that, when you're looking at expanding clusters, you can shrink and grow based on the fin provision volume. You can simplify that cluster node upgrade because of that capability, and really kind of obtain increased operational improvements for all of these additional features in the cluster. So really kind of adding some increased value there. So making you aware of these and these being there out of the box is going to be really important. So let's move on to now compute capabilities. Now, some of these new capabilities follow the same operational theme to make things easier, to complete things quicker, to ensure higher availability. I mean, these new capabilities enable the following: quicker time to reboot, less data to resync, easy to expand clusters over 3 to 5 years as process innovation increases, support for GPUs, and support for nested virtualization and AMD support. Now, let's kind of dive into each of these again. So if we start with dynamic CPU compatibility, this is an Azure Stack HCI 21H2 capability only. This essentially allows you to mix and match processor versions and steppings in the same cluster. All cluster nodes require to be either all Intel or all AMD. It's not advisable to mix those because the processor compatibility won't help you there because they are completely different processor instruction sets. This is on by default within the cluster. So once you've implemented Azure Stack HCI 21H2 or upgraded to 21H2 and your cluster function level is set to 11, which is the level of 21H2, this enables this capability. So with this enabled, by default, it aggregates the common processor features between all Intel or all AMD nodes in the cluster, depending if you're AMD implementation or an Intel implementation, and can be enabled for every virtual machine to leverage within the cluster. For example, this enables live migration between a Cascade Skylake and Ice Lake Intel processor, but not between an Intel and AMD process in the same cluster. You have to stop the VM, move that over and start the VM to reinstantiate the new processor set. So again, this allows you to mix Intel processors or mix AMD processors depending on what your processor choice is. Now, also, please be aware that the virtual machine requires a minimum version 10 to support this capability within the virtual machine. This had the added benefit of supporting the expansion of cluster nodes with later processes. So imagine you buy a solution for 3 to 5 years. The innovations coming from Intel and AMD, it's continuous. Every 12, 18 months, there's new processor versions coming out, and older processors go end of life quicker. And so, as you want to expand, cluster nodes, it's likely that you're not going to get the exact processor being available. So this allows you to mix and match Intel processors and still support live migration. And also this allows you to think about, in years to come, the ability to roll out old nodes and roll in new nodes and new processors and still be compatible. Still, because live migration would still work between those, that aggregation of common processor feature sets between all nodes in the cluster. So again, it gives you that 2 added benefits there. You can also enable compatibility mode on each VM to support live migration between clusters that have different processor versions or stepping, as well as between nodes within the same cluster. Okay. On to the next area. Now, nested AMD is again an Azure Stack HCI 21H2 capability only. This has been a long time coming. Many customers have asked for this, but a big note here, this is not for production, but more for test and development only. This also requires VM version 10 to support this capability. You can run nested virtualization on first generation AMD EPYC processors or newer generations, Naples, Rome, and Milan. But this also requires the AMD Secure Virtual Machine or AMD Virtualization, AMDV virtualization enablement to switch on to light up this capability. Now onto a kind of an interesting area. Clustered virtual machines, highly available virtual machines and GPU support. This again is supported on Azure Stack HCI 21H2 only. This supports DDA, which is a discrete device assignment, providing a one-to-one mapping for a GPU to a VM. So essentially you can assign multiple GPUs to a single VM. Most modern systems today with GPUs can support 3 or 4 double width GPUs, providing for 6 or 8 VMs per node. And for kind of the today kind of AI type workloads at the edge, it's a start point. But in the future, when AMD GPU-P, GPU partitioning, and NVIDIA MIG multi-instance GPU are available, will provide further improvements in scale and density on this platform. This also enables, highly available clusters of VMs to be associated to a GPU through a cluster resource pool. So when the VM fails over to the second node, we'll find a common resource pool name and associated GPUs to that for it to leverage and to continue processing. So if you imagine you've got a 2-node cluster, you create a resource, a GPU resource pool on node 1. You create the same name GPU resource pool on node 2. You assign the GPUs to each pool on each node, and then on node 1, you assign the virtual machine to that resource pool. When node 1 is switched down or the VMs are drained, that VM will fail over to node 2. It's not a live migration, it's a failover. So essentially what it's doing is stopping the VM, moving it over and starting the VM, but it's able to pick up the resource pool and GPU on the second node and continue processing. Now in testing on, running workloads that leverage GPUs and on that failover, there was a kind of a 3-minute kind of time period for the failover of the node, for the VM to shut down to move over, and for it to start over, and for that VM to start up, and for the application to start up, to pick up that new GPU and continue processing. The main point here, it was automatic. There was no intervention from me. Whereas in the past, that was not available. DDA and GPU support was single node only. There was no high availability. There was no failover. So this is the next step in supporting high availability with GPUs on Azure Stack HCI 21H2. Kernel soft reboot, or KSR for short, is an interesting technology that exists in Azure. Remember I mentioned about those 1 million Azure nodes in Azure? This is a technology that's leveraged there every day. If you imagine having a million nodes, having to, minimize the reboot time of each of those nodes, reduce the patched time for each of those nodes, and proven at hyperscale. These types of technologies are coming to Azure Stack HCI, and this is, some of the first of that technology. So kernel soft reboot is an interesting one. So OEMs will be providing a KSR ready system as part of their integrated system offerings, and we'll need to check with OEMs which validated nodes will also be certified. This is really key message here. If you want to leverage KSR, it should only be on approved systems from each OEM that's KSR tested validated. If you buy an integrated system, you're guaranteed with that from each OEM, and it's optional for the validated node. So please check, with each of the OEMs support for KSR for you to light up that feature. This will be integrated with clusterware updating, and where CAL recognizes that the update can benefit from KSR, will be enabled for use. For example, most Windows Server patch updates will fall into this category. So if you imagine that, it's a patch update Tuesday, I'm submitting that change to Windows Admin Center, and it gets submitted to clusterware updating. Clusterware updating recognizes that KSR can support that. KSR will then not do a full post reboot after patching, it will do a kernel reboot only. And so, as an example, in testing that we've completed on a Dell AX640 all flash with 96 gig of RAM integrated system, this took 23 seconds with a kernel soft reboot, compared to a 2.5 minutes for a full reboot. And why is this important? Well, because of the speed of reboot is such a difference, the granular storage tracking of Spaces Direct is far less. So you're going to be invalidating less extents and slabs. When the node comes back up and rejoins the cluster, it's going to be less to resync. So essentially, you're reducing the boot times, you're reducing the resync times of Spaces Direct, and you're able to then move quicker to the next node to complete its patching. Again, overall reducing the time to patch the solution. So again, following that same theme of reducing that operational time to patch, to manage, to watch, to make this more automated. So, but on a side thing as well, this doesn't apply to OEM BIOS firmware and driver updates. These still require a full reboot. This only applies to the majority of Windows updates. And as we go forward, hopefully the upgrade from different versions of Azure Stack HCI to support that as well, to reduce the time it takes to complete your upgrades. So as we bring all of these improvements together, again, as customer benefits, and thinking about these, high availability in GPUs are becoming an increasing requirement at the edge as more data is being intelligently processed before aggregating and sending data to the cloud. To support the mix and match of same processes in the cluster makes node expansion over 3 to 5 years far simpler. Rolling old servers out and rolling new servers in while maintaining business continuity is also now a possibility. And live migration between clusters with same vendor version processes is also now possible. There are some real great improvements here, helping to bring further agility and mobility to on-premise. A side note here as well, in terms of feature enablement, and it's one to really keep your eye on. When updating to Azure Stack HCI 21H2, some features require the cluster function level to be raised to 11. The same for updating the storage pool version. The list in front of you covers the primary areas. So imagine I've now upgraded from 20H2 to 21H2, or from 2019 or 2016 to 2021H2, and I want to enable thin provisioning. Well, I have to go into Windows Admin Center or through PowerShell and update the storage pool to the next revision, and then that will light up thin provisioning. The same for with 21H2, you have to unregister from Azure Stack from Azure itself and re-register, but you have to make sure the cluster function level is set to 11 to enable the Azure Arc at the node level, that capability at the node level. And the way that you tell that the cluster function level has not been enabled is that when you deregister the Azure Stack HCI from Azure and re-register, you won't see the option for Arc enablement. So to keep an eye out for that. And dynamic CPU compatibility, again, requires CPU function, the cluster function level to be set to 11. So just keep an eye on those areas. If you're not seeing the capability, go and check your function level of the cluster. So now on to network improvements. There are some interesting kind of improvements here. Network ATC, encryption, AS256 SMB encryption with support for RDMA offload, and the upgrade of SDN from 20H2 to 21H2 is now in place. So let's start with network ATC. Network ATC is an intent-driven service that runs on every cluster node. Its job is to simplify the implementation of core networking or ensuring the latest Microsoft best practices are always implemented with drift control. So when you expand the cluster with a new node and you ensure the same network adapter slots and naming is in place, this will automatically receive the same intents and Microsoft best practices and duplicate the network configuration, making it simple and easier. Now, this is really important if you're thinking about putting software-defined network on top of your core physical networking, because this, will ensure that all your best practices are in place, all your nodes are exactly the same configuration, and if someone changes something on one particular node, it will put that configuration back. It maintains drift control. That's really important over the life of a solution. So I recommend that you really kind of look at this capability and leverage this within your HCI solutions. And I think also, so imagine that, I've got a 4-node Azure Stack HCI 21H2 cluster, and I made a mistake and I deleted some virtual NICs or I deleted the virtual switch. Network ATC will recognize that and re-implement the network switch and the network adapters, the virtual adapters. So correcting that and standardizing that. So what if I change, the RDMA settings in terms of DCB, PFC, ETS, and someone changed, on a particular node and caused problems with RDMA, this would pick that up and put those changes back in and standardize again. Okay. Now, this is where the kind of networking baseline is going in terms of best practice and drift control from Microsoft. But this doesn't mean that, that's the best practice and you cannot change this. You are also able to change the intents and override them and adjust these to your best practices and ensure these are maintained with drift control. So a very good feature. I recommend that you really look into that. SDN upgrade. Now, this has always been a challenge in the past for an upgrading from one release of operating system in terms of a solution to another. Now, in 20H2 to 21H2, SDN support is there. So essentially what that means is if you've got the 7C July update in place, or after you've before you've updated the OS from 20H2 to 21H2, it will then support SDN upgrade and enablement. So imagine you have upgraded from 20H2 to 21H2, 7C is applied, SDN will continue. SDN virtual machines are running on 20H2, the hosts are running on 21H2. I can then, on each VM, the network controller, the MUX, the gateway, upgrade the OS to 21H2, and because I've got a highly available service, free network controllers, free gateways, free MUXes, load balancers, I can enable that and stay and maintain business as usual from my SDN. Now, going forward, wouldn't it be great that SDN upgrade is tied into clusterware updating? So essentially, as you upgrade the host, you can then upgrade the SDN, and clusterware update manages it automatically, and you just sit back and watch it happen. So again, a very good improvement there with SDN. Now onto an interesting addition to Azure Stack HCI 21H2, and this is only again on 21H2, is the support for AES-256 encryption for SMB and support of RDMA offloads. Now, I don't know if you ever come across a problem where if you install an Azure Stack HCI into a government location, with lockdown policies, and you don't, block the policies or disable override of policies, and the domain lockdown for SMB signing is applied to your Azure Stack HCI nodes, that can really cause impacts to RDMA because RDMA is not functioning fully. And that affects IWARP and Rocky in similar ways. And that really caused, timeout issues on the storage fabric and intermittent issues to occur. So up to now, we've recommended that, when you install Azure Stack HCI, you put it into its own organizational unit, you block inheritance, but you make sure that none of the policies have override, because if you set a policy on the parent above the OU and override, the block inheritance doesn't stop the policy, and it will just set that SMB signing all over your cluster, causing the same problem. Now with this capability in 21H2, we don't have that problem anymore. SMB signing and encryption is now supported on RDMA offloads. So again, improvements that really kind of help alleviate challenges and problems. So with that, this kind of brings us to the end of the presentation, and moving on to the next slide. In terms of networking, we really come down to this simpler upgrade of SDN, simpler node expansion, because we've got some. We've got better control in terms of network drift. We've got better control in terms of upgrade. So we're automating more and having less problems, because in the past we've had all these problems. And I think taking all of these storage, network, and compute areas that we've covered, you can see the theme here. It really is to reduce the amount of reboots. It's to reduce the amount of resyncs on storage. It's to make reboots quicker. It's to make expansion quicker, and to really kind of address the problems of the past. Specifically, I'm pointing to the encryption for RDMA and with SDN upgrade support. These are very welcome incremental differences to the platform. So as we go into our kind of closing part of this session, I just want to give you an awareness of our next session on the 30th of September, based on Azure Stack HCI 21H2 again, but focused on high availability and disaster recovery, because this is an inherent requirement of hybrid cloud. And so we're going to discuss stretch clustering and why this should be the first consideration for your on-premise solution. And so to that, let's jump into Q&A. So Craig, do we have any questions?
Hi Jerry, thanks for that. Hope everybody found it informative from both yourself and Lee. And yes, we've got a few questions. So let's start off with the first one. 2 seconds. Difficult, I had it up on the screen, it just disappeared. So the first one was will Hyper-V and storage replication work between 20H2 and 21H2 clusters?
Yes, they will work. There is no API or Azure support policy block between 20H2 and 21H2, as exists between 2019 and 2016 and 20H2. So yes, they will work.
That's good news. The second one is, are there any manual post tasks needed after upgrading to 21H2?
Yes, there are. So when you upgrade to 21H2, as I mentioned earlier, you've got to make sure that your cluster function level is set to 11. So you're running in 21H2 cluster function level. And why is this important? The reason why is you have to deregister your Azure Stack HCI from Azure and re-register to enable the Azure Arc capability at the host level. And why is that important? Well, you want to enable, multi-cluster monitoring, update management, security defender, your hybrid capabilities through enabling this Azure Arc node capability. So very importantly that you complete that manual task as a post item.
Perfect. Next question was around the feature set, and it's, will all the new features be unlocked after upgrading to 21H2?
No, they're not. So again, storage, for example, if you imagine that cluster function level, again, needs to be set to 11. Now, as you upgrade from 20H2 to 21H2, the process will give you an option to select upgrade to cluster function level. But what happens if that doesn't happen? What happens if there's an interruption in the upgrade process? And so please check for cluster function level has been completed. So that will switch on your storage throttle, that will switch on your Azure Arc enablement and your CPU, dynamic CPU compatibility. But the last one is that you need to update your storage pool level to enable thin provisioning. So they're the things you need to consider after upgrading 21H2.
Perfect. Another one is, can my service provider manage my Azure Stack HCI cluster via our subscription?
They can, but typically a service provider would use a capability called Lighthouse, which allows the service provider to manage multiple subscriptions by projecting those resources into the Lighthouse architecture. And so they can manage the Azure Stack HCI and the resources around that as an MSP, not just one customer, but multiple customers and multiple subscriptions. Yes, you can.
Next question is, can you assign more than one GPU to a VM?
Yes, you can. You can assign multiple GPUs to a VM, and for this VM to support high availability, so it can fail over from one node to another. So really it comes down to when you set up the resource pools for GPUs on each node, is that you assign those multiple GPUs in a common way, in a consistent way across those nodes. So when you assign that VM to the resource pool and it's connected to those two GPUs to that one VM, when it fails over, it needs to find that same consistent configuration in terms of resource pool and GPU assignment, and that will work automatically. Yes, it will.
Good. Next one is around our own stuff, and it's, what are Architect's hybrid cloud offerings?
Yeah, so if you take the, we have managed services offerings, in terms of Azure Site Recovery, disaster recovery, backup solutions, a whole raft of those. We have Intune, Autopilot, endpoint management, SCCM integration, you name it. We have a raft of hybrid services that we offer, and love to be able to take offline and spend time to go through them because there's so many.
And then the last one we've got here is, what are the expected features missing in Azure Stack HCI?
That's a trick question.
Yeah. What would like to be seen in there, I guess, is here.
There's lots of features that are coming, that are in the works, and so what does it mean? Because innovation is happening twice a year. So if you think that 21H2 is later this year, and then we've got 22H1, which is the first half of next year for the next release. Public preview will come out first, so you can evaluate those new capabilities. You're just going to get innovation on innovation on innovation. So there are lots of new features coming. Obviously, we can't talk about those in this session, but they will be equally as impactful and equally as interesting for on-premise and hybrid services.
Perfect. And I think that's all the questions that we've got. Yep, in there at the moment.
Let's wait for a few minutes and see if there's any more questions to come in. Okay, if there's no more questions, let's bring this to a close. Thank you very much. And Lee, thank you very much for presenting with me.
Thank you.